Okay, guys, so we're going to do chapter 7, or at least the first part of chapter 7 from chemistry. This chapter is stoichiometry. Stoichiometry allows you to figure out how much of each ingredient you would need for a chemical reaction to occur. So a chemist needs to know how much of A and how much of B do I need to put together to actually get C and D from this chemical reaction that we've talked about. Remember, the number under the chemical symbol on the periodic table is the atomic mass in AMUs. So, the first thing we need to remember is how to convert from AMUs to grams. So, if you remember, we did that early in the chemistry. So, there are 1.66 times 10 to the negative fourth grams in 1 AMU. So 1 AMU equals 1.66 times 10 to the negative 24th grams. You should have that on your cheat sheet. If you don't, you can write it there. It's also on page 197 of your chapter. Okay, so for instance, if we have helium, if you look on the periodic table right under HE, it says 4.00 AMU. And so remember our factor label method. AMU is up here, so AMU needs to be down here so they can cancel out. And we are looking for grams, so it needs to go up there. AMU cancels out, and then we use our conversion factor, 1.66 times 10 to the negative 24th in 1 AMU. Then we put this into our calculator. Your calculator should have an EE button, and that's usually the scientific notation button. When you put this in, you should get 6.64 times 10 to the negative 24th grams. If you don't get this answer, then you're not putting it in your calculator correctly. Okay? This is the answer you should get, or somehow you've not put it in your calculator correctly. So, if you can't figure that out, please let me know so we can figure out how to do it on your calculator. It's usually going to be a button that says EE. It's not one that looks like a little top hat usually. Those are other functions. So, and you can't just type in times 10 to the negative 24th. That doesn't work. You got to use that little EE button. Is usually where it's at on your calculator. Okay? So, we talked about Avogadro's number. Avogadro's number. That's 6.02 times 10 to the 23rd. We call it a mole. Remember, you figure out how much different a mole of different candies would weigh. So, a mole of a substance is 6.02 times 10 to the 23rd units. That could be atoms or molecules or ions, depending on what we're talking about. So, if I said I have a mole of sodium chloride, that means I have 6.02 times 10 to the 23rd molecules of sodium chloride. If I say I have a mole of hydrogen, I have 6.02 times 10 to the 23rd atoms of hydrogen. It's just like saying I have a dozen eggs, I have a dozen donuts, I have a dozen apples. Doesn't matter what we're talking about, it's still the same amount of things. We can use to convert between mass and the number of particles of something. Okay, so if your periodic table, the number under the element symbol, the mass number, it's going to tell you the mass of a single atom in AMUs. And there we can find grams from there, but it tells you the mass of a single atom. It also tells you the number of grams you need to collect to have a mole of those atoms. That can feel a little confusing. But that number is the number of grams you need to collect to have a mole of those atoms. That's the molar mass. So remember on our little cheat sheets I handed you, it talks about molar mass. It's just the number under the symbol on the periodic table. Okay, so if I want a mole of calcium, we can look at our periodic table. The number under calcium which is Ca, is 40. I think it's 40 point. Let's see. 40.08. Use the decimal points they give you. So 1 mole of calcium is 40.08 grams. Okay, so to find the mass of a molecule, and that's what, trying to remember how far ahead your assignment is, but I don't remember off the top of my head. Okay, so we're going to do example 7.1 together. We're going to find the mass of a single molecule of C6H12O6. So they start with the big one here. What is on the worksheet? Let me look at the worksheet I gave you. Yeah, okay. So now I gave you the extra worksheet, not to be mean and give you a lot of extra work, but because the more of these do, the more second nature it'll become. And I will post the answers for the worksheet probably tomorrow or Friday. Please don't just look at the answers. Please do the problems and then check your answers. If you have trouble, please let me know. Come over and get some help. Do a video call with me. We will spend Tuesday in class working through problems and but there's a little bit more we need to also do. So please try to have this concept kind of cemented. And if you need help, please, 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 please ask for help sooner rather than later. I know the math stuff is kind of, but once you can do it, you can do it. And it's not as tricky as, it feels trickier than it is because it has these really big numbers. But if you just pretend it was 12 or 10, you're just putting a different number in there. Okay, so don't, you guys can all do this. Promise, promise. Okay. I taught chemistry to some kids when I taught in high school. You guys can do this. I know. You guys are awesome kids. What is the mass of a single molecule of C6H12O6? So C6H12O6. This is glucose, by the way. So what you need to do is find the mass, the molar mass of this molecule by adding up the mass of 6 carbons, 12 hydrogens, and 6 oxygens. Okay, so the first thing we need to do is look at carbon on the periodic table, and it has a mass of 12.01. So we do 6 times 12.01. 6 times 12.01 is, did I not write that out? Okay. Let me use my calculator because I want to. 6 times 12.01. The book kind of skips steps, and I think trying to you can put the whole long thing into your calculator if you know how to use it. But if you don't, just do it step by step. Don't rush it. Okay, now we need to do hydrogen. Hydrogen is 12 times 1.01. Let's see, clear. I'm using Adam's calculator, and I'm not used to using it. So, plus 12.12. Oxygen is 6 times 16, right? Yep. 6 times 16. And you have 96. So you add 72.06, 12.12, and 96. And we get 180.18 AMUs. This is the molar mass. We just took this number times what the periodic table said. This number times what the periodic table said. Okay. And then we can use our cheat sheet to look at what we know. We know, let's see, what did it say? It says, what is the mass of a single molecule of this? So a single molecule, this is what the mass of a single molecule is. Is 100, that does not look like an 8. 180.18 AMUs is a single molecule. We just add up each individual component of the molecule. Okay, so now that we know that, and then it says, what is the mass of a sample of glucose if it contains 6.02 times 10 to the 23rd molecules? So, we know it has 6.02 times 10 to the 23rd molecules. And we want to know its mass, right? Oh, this is kind of a silly question. I realize what it's asking. So 6.02 molecules is 1 mole, right? That means that is the same answer. 1 mole is going to be what you get off of adding them off the periodic table. That is 1 mole. Okay. I feel like that was kind of a... Okay. Let's look at 7.2. It says a student measures out 15.6 grams of magnesium chloride. Okay. We need to know what magnesium chloride is. Do we have a prefix? No. If it does not have a prefix, is it ionic or covalent? It is ionic. So we need to go magnesium and chlorine. Magnesium has a charge of +2. Chlorine has a charge of -1. We swap them and it's MgCl2. First step, we got to know what we're dealing with. So, we now know it's magnesium chloride. How many moles does he have? So we have 15.6 grams, and we want to know moles. So we can look at either chart. So if we want to look at this chart, the top one, we have mass, and we want to know moles. Mass divided by the molar mass will give us the number of moles. Same thing down here. Grams divided by molar mass will give us the moles. So we need to do, we have the grams and we need to divide it by the molar mass. So we need to figure out the molar mass. Magnesium has an AMU of 24.31. There's only one of them. Chlorine, there's 2, and its molar mass is 35.45. So we'll multiply that together first. 2 times 35.445 is 70.9 plus 24.31. So we get 95.21 is our molar mass. These numbers came from the periodic table. So we take our molar mass and we move it up here, 95.21. So 15.6 divided by 95.21 is going to give us 1.16384833353. Okay, this is where our sig figs come back in. 3 and 4. We do 3 sig figs. 0.16, then it's a 3, so there it stays. Oh, actually, the number after 3 is 8, so we round to 4. 0.164 moles. Okay. So let's do... Okay. Then it says, how many molecules of magnesium chloride does she have? So we know moles. So if we look here, we know moles and we want to know molecules. So moles times Avogadro's number will give us molecules. Same thing down here. Moles times 6.02 times 10 to the 23rd will give us molecules. So we can do that. I'm going to erase some of this. All we need left is how many moles we have. 0.164 moles times 6.02 times 10 to the 23rd. And when you put that in your calculator, you should get 9.87 times 10 to the 22nd. Molecules. Don't forget to label what you have. 9.87 times 10 to the 22nd molecules. If you put this in your calculator and you do not get this, you need to talk to me. Okay? We need to make sure you can put that into the calculator. Okay. So, let's try. Stay. Okay. Let's try another one. Let me look at your extra assignment sheet that you have. Yeah. Okay. So, let's do sodium chloride. So, sodium chloride. There are no prefixes, therefore it is ionic. So sodium is +1, chloride is -1, NaCl. Okay, let's say we have 62 grams and we want to know how many moles we have. Okay, so to go from mass, our grams, to moles, we need to divide by the molar mass. So we need the molar mass. The mass of Na is 22.99. The mass of chlorine is 35.45. There's only one of each. So 22.99 plus 35.45 is 58.44. Okay, so again, grams divided by molar mass. So 62 divided by 58.44. 62 divided by 58. I'm sorry, 58. Can I go back? 58.44. Okay, 2 and 3. So we're only going to choose significant figures here. So it's 1.1 moles. Start with what you know. So if it says how many moles are in 40 grams of water, you know grams. So you start with the mass and you're going to moles. You're starting with the mass, you're going to moles. If it says how many grams are in 3.7 moles, you are starting with moles and going to mass. Start either mass, particles, or moles, and you're going to either moles, mass, or particles. Or you can use the one down here. Either chart will work. Start with what you know, look at where you're going, decide if you're multiplying or dividing, and use what numbers you're using. Okay? So like I said, if you have trouble, please, please, please ask me sooner rather than later. If you finally figured it out by the end of this and you need more practice, let me know and I will find more practice problems. This is very important that we understand how to do these, but you can do them, okay? I know you can do them. Okay, so we are going to leave it there for today. Yeah, the only other thing, and I don't remember how far I told you to do on your assignment, talks about hygroscopic, which means readily absorbing moisture. So something that's hygroscopic will absorb moisture. Yeah. And then we will work on the second half in class next week of chapter 7. So you guys can really cement some of these ideas down, because the more you do, the easier it becomes because you do it over and over and over. Okay, so let me know if you need any help.